Welcome to our group presentation. Our group is Music Preferences, Personality Traits, and Academic Performance. For our presentation topic for today, we have objective, how we collect the data, nominal data, ordinal data, numerical data, and correlation. For the objective, we choose this project because music is a big part of a student's life, but its impact is rarely examined. We were curious whether music habits and why students listen have any link to GPA or study patterns. How we collect our data. We collect our data through Google Forms to collect over 103 responses. We created over 19 questions covering music habits, academic behavior, personality traits. The survey includes numerical, ordinal, and nominal data. We distributed our forms by using line groups and social medias to see a more diverse both Kasesa University and other students. Anonymity. We made sure that our survey responses were anonymous to ensure data privacy and ensuring honest answer. For the data quality, we check the data and clean the data to ensure accuracy and maintain the response. For the descriptive statistic, first one is nominal. As you can see, on the top left is a graph of the gender ratio. Next is the graph of personality type. Next is a graph of music platforms. And lastly is the listening styles. Next one is nominal data. As you can see, we have one for language of music that people prefer to listen, emotional, connect through music, and time of the day to listen to music. For the ordinal data, we have the importance of music in life. As you can see, most people see that music is a very important part of their life. And then the impact of listening to music on academic performances. As you can see, it is very spread out and seem to have no clear pattern.
For single data analysis, in this part, we will explore the script statistic, the goodness of its test and hypothesis testing for numerical data. We will go through the test and examine how the data behaves statistically, making it easier to understand the overall trends and patterns. Now let's move on to the playlist data. We're using the goodness of its test to see if the number of playlists per student follows a normal distribution. The null hypothesis HO assumes that the distribution is normal and the alternative hypothesis or H1 suggests it isn't. The statistic is 208.2265, which fall to the rejection region, so we reject the null hypothesis. This means the distribution of playlist counts doesn't follow a normal distribution, and we have enough evidence to reject an HO. In addition, we have provided some summary statistics like mean, median, and standard deviation to better understand the data spreads and settle tendencies. Let's take a closer look at the hypothesis test of the average number of playlists. We are testing if the average number of playlists is equal to 8. The test statistic we calculated is 0.7026 and based on our significance level and alpha equal to 0.05. We compare it with the critical value of 1.6449. Since the statistic is less than critical value, we fail to reject the null hypothesis. This suggests that there isn't enough evidence to support the claim that the average number of playlists is higher than 8. Therefore, we conclude that the average number of playlists is likely to be 8 or less. So, we have histogram for the number of playlists. This graph shows how many students have different numbers of playlists. Let's move on to the music listening hours while studying during non-exam periods. We're using the goodness of its test again to see if this data follows a normal distribution. The null hypothesis or HO assumes normality, while the alternative hypothesis H1 suggests otherwise. The test statistic is 28.2067, which falls into the rejection region, so we reject the null hypothesis. This means that the data does not follow a normal distribution, indicating a skew in the music listening habits during non-exam periods. We have also included measures like mean, variance, and standard deviation to summarize the data, providing insight into how much students engage with music while studying. Here, we perform a hypothesis test to check if the average music listening time during non-exam period is greater than 2.5 hours, with the statistic calculated as 0.4789 and a significance value of 0.05, we compare it with the critical value of 1.6449. Since a test statistic is less than a critical value, we fail to reject the null hypothesis. This suggests there isn't enough evidence to claim that the average listening time is greater than 2.5 hours, So we conclude that the average music listening time is likely 2.5 hours or less. Let's take a look at the histogram for music listening hours during non-exam periods. The x-axis shows the number of hours spent listening to music, while the y-axis shows the frequency.
And now we are going to present largest GPA. Goodness of fitted. No hypothesis. The distribution of student largest GPA follow a normal distribution. Alternative hypothesis. The distribution of student largest GPA does not follow a normal distribution. Conclusion. Since the test statistic 7.54174 into the non-rejection region, therefore, no hypothesis is not rejected. This means that the observed data follow the normal distribution and there is no enough evidence to reject no hypothesis. This is graph largest GPA histogram. Okay, and this is sleep hour per night non-exam. Goodness of fitted. No hypothesis. The distribution of sleep hour during non-exam period follow a normal distribution. Alternative hypothesis. The distribution of sleep hour during non-exam periods does not follow a normal distribution. Conclusion. Since the test statistic 14.96044 into the non-rejection region, therefore no hypothesis is not rejected. This means that the observed data follow the normal distribution and there is no enough evidence to reject no hypothesis. And this is histogram of sleeping hour per night non-exam.
For the next part, which is the correlation for the first pair, which is the music listening time during exam and non-exam period, we found that there is a moderate positive correlation around 0.59 between the two periods. This means that students will listen to more music during non-exam periods tend to also listen to music during exams too. And for the conditional probability, we let A be the event that the average daily music listening time during non-exam periods exceeds 5 hours, and B be an event that the average daily music listening time during exam period exceeds 4 hours. Given that a person listens to music for more than 4 hours during exam period, there's a 36.84% chance that they also listen to music for more than 5 hours during non-exam periods too. This suggests a moderate correlation in music listening habits between the two periods, which adhere to the correlation plot that we have done. And for the next pair, which is the music listening time while studying during the non-exam and exam period, we found that there is a moderately positive relationship between the two periods. This implies that students will listen to more music during non-exam periods, also tend to listen to more music during exams too. But academic pressures may still influence their behavior. And for the conditional probability, we let A be the event that the average music listening time during non-exam periods while studying exceeds 3 hours, and B be the event that the average music listening time during exam periods while studying exceeds 2 hours. For the conclusion, we found that given that a person listens to more than 2 hours of music during exam period while studying, there's an 86.36% chance that they also listen to music for more than 3 hours during non-exam period. This suggests a moderate correlation in music listening habits between the two periods, which adhere to this histogram that we have done. And for the next pair, which is the latest GPA and student listening times during non-exam period. For the correlation, the scatter plot shows no relationship between study hour during non-exam periods and GPA. The data points are widely scattered, suggesting that studying time alone does not strongly correlate with GPA, implying other factors may also influence academic performance. For the conditional probability, we let A be the event that students who have GPA exceeds 3.0, and B be the event that students who study for more than 4 hours a day during non-exam period. Conclusion, we found that given that a person studies for more than 4 hours per day during non-exam period, there is an 89.74% chance that they also have their most recent semester GPA above 3.0. This suggests a moderate correlation between study hours and academic performance, which contradicts to the correlation that we have done with the plot. This might be happen because there may be many factors that have been happening. And for the last pair, which is the sleep hour during exam and non-exam period, the scatter plot of sleep hour during exam and non-exam period show a very weak negative correlation. That is, students will sleep more during exam nights tend to sleep slightly more or less during non-exam nights. This relationship is weak and not clearly linked. For the conditional probability, we let A be the event that students who sleep more than 1 hour during exam period, and B be the event that students who sleep for more than 2 hours during non-exam period. For the conclusion, although the correlation is weak, the conditional probability suggests a moderate consistency in sleep behavior. This suggests that students who value their sleep outside exam period are likely to maintain similar habits during exam, which implies that some students may practice good time management or have a stable self-care routine. And here is the correlation part that we have done. And the last part, this is our member, and here is our group member. So what I want to say is thank you for give us an opportunity to present our project. See you next time. Thank you.